Hello and welcome to anyone tuning in to video 3 of our Functions and Equations unit for IB Math HL. In this video, we'll be going over 3 questions that help apply knowledge to exam-style questions. If you haven't seen our previous 2 videos on Functions and Equations for IB Math HL, please go and check those videos out. Now, without further ado, let's begin with the first question. Question 1 asks us to find the combinations which map the function f of x, 2x squared minus 12x plus 15, into the function g of x, which is 3x squared plus 6x plus 7. And here, since we're trying to find the combinations, we'll be solving for every translation, left or right, and stretch or contraction that's needed to make the function f of x onto g of x. In order to do that, first we're going to be rewriting the function f of x into vertex form. So the first step here would be to write f of x as 9 over 2x squared minus 3x plus 9 over 2, which is also equal to 1 half factored out inside parentheses 9x squared minus 6x plus 1, and an additional 9 over 2 and negative 1 half on the outside to make sure that the function is equal. This will all simplify out into the vertex form of half times, in parentheses, 3x minus 1 squared plus 4. Now that we have f of x, next we'll be finding the vertex form for the function g of x. Here, we can rewrite g of x as 12x squared plus 60x plus 74. Once we do that, we can factor out 3 to make the function 3 times 4x squared plus 20x plus 74. And in order to make the inside of the parentheses a perfect square, we can rewrite the equation as 3 times 4x squared plus 20x plus 25, with an additional 74 and negative 75 on the outside. This comes out to g of x is vertex form being 3 times 2x plus 5 squared minus 1. Now that we've found the vertex form for both functions f of x and g of x, we just need to rewrite g of x in terms of f of x. This will come out to the form af times 6 times x plus c plus d. When we first substitute f of x into this equation, we'll come out with a times half times 3 times b times x plus c minus 1 squared plus 4 plus d. Once we simplify everything to make sure that the g of x is equal to its original vertex form, we come out with 6f times 2 over 3 x plus 3 minus 25. This gives us our final answer of a equals 6, b equals 2 over 3, c equals 3, and d equals negative 25. Therefore, g of x equals 6f times 2 over 3 times x plus 3 minus 25. This indicates a vertical stretch by a factor of 6 and a horizontal stretch by a factor of 3 over 2. The translation in this case will be negative 3 horizontally, or 3 units leftwards, and negative 25 vertically, or 25 units downwards. And there can also be a translation of negative 2 horizontally and negative 4.16 vertically with the same stretches. Question 2 asks us to solve for x in 2x plus 3 over x minus 1 in absolute value when it's greater or equal to 2. First, we'll split the absolute value into its two equal parts, the positive and negative. In doing this, we need to make sure that we can identify when each of these exist. For example, in the positive side, x has to be greater than 1 or less than or equal to negative 3 over 2. On the other hand, on the negative side, x has to be greater than negative 3 over 2, but less than 1. From this, we can try and find both functions when they're equal to 2 to solve for x. On the positive side, we have 2x plus 3 over x minus 1 is equal to 2, which simplifies out to 2x plus 3 equals 2x minus 2, which doesn't exist. Therefore, we can fully ignore this part of the question. On the negative side of the function, we have negative 2x minus 3 over x minus 1 is equal to 2. By simplifying this, we get negative 2x minus 3 is equal to 2x minus 2, and therefore 4x equals negative 1, and x is equal to negative 1 over 4. Hence, our answer will be x is greater than negative 1 over 4, and x cannot equal 1. Moving on, question 3. If px is divided by x minus a times x minus b, where x cannot equal b and a, b are elements of the reals, prove that the remainder is pb minus pa over b minus a times x minus a plus pa. First, by the remainder theorem, we can tell that px is equal to x minus a times x minus b times qx plus cx plus d. Hence, p of a will equal ca plus d, and p of b will equal cb plus d. Using these two equations, we'll find c, which is equal to pb minus pa. And therefore, c will become pb minus pa over b minus a. Next, we'll substitute the c value into the equation of cx plus d so that we can find the equation for the remainder. Substituting this will be equal to pb minus pa over b minus a x plus pa minus ca, since d is equal to pa minus ca. Once we do this and simplify, again, c and substitute it with pb minus pa over b minus a, we'll come out with pb minus pa over b minus a times x minus a plus pa. Therefore, the remainder will be pb minus pa over b minus a times x minus a plus pa. And there we have it, 3 exam-style questions on functions and equations for Math HL. If you found this video helpful, please feel free to see some of our other content explaining IB math or physics through our channel. Thank you for watching, and we'll see you next time.